Hello, I'm Nur Farina Fatin binti Abdul Muttalib, and for my part, I will explain the geological background of the Ranau area in Sabah, Malaysia. The Ranau area in Sabah is located on the Sunda Plate, which is part of the Eurasian Plate. Although this region is not directly on a major plate boundary, it is affected by tectonic stress from nearby active plate boundaries in Southeast Asia. The Ranau Kundasang contains several local fault systems, showing that the area is not completely tectonically stable. When stress builds up along these faults, it can be released suddenly as an earthquake. The geology of the area is also influenced by Mount Kinabalu, which is mainly composed of granitic rocks. These rocks contain fractures and weaknesses that can be reactivated under tectonic stress. The 2015 Ranau earthquake had a shallow depth about 10 kilometers, which caused strong ground shaking at the surface. Overall, the combination of tectonic stress, local faults, and complex geological structures explain why earthquakes can occur in the Ranau area. All in all, although Sabah is not located on a major plate boundaries, stress can still build up in the Earth's crust and be released as earthquakes. That's all from me. Thank you.
Hi, my name is Prem Zamili with the matrix number of BS23110085. I will be presenting the tectonic setting and the seismic activity section. I'll be explaining the regional plate movements and zooming in on the specific active faults that caused the 2015 Ranau earthquake. Sabah is under constant pressure. The Philippine Sea Plate pushes from the east and the Celebes Sea pushes from the southeast. This regional compression reactivates ancient weaknesses in our crust, creating the massive Crocker and Mensaban fault zones. In the Ranau district, the stress is concentrated at a critical intersection. As shown in the poster, the active Lobo-Lobo fault crosses the Masilo fault right at the foothills of the mountain. For years, these fractures were accumulating silent energy. On June 2015, the silence broke. This fault ruptured, triggering a magnitude of 6.0 earthquake. The focal mechanism confirms it was a normal faulting event. So this means that the ground literally pulled apart and dropped due to extensional stress. The impact was devastating, triggering over 5,000 landslides. This event proved that Sabah's fault systems are active, and that understanding these hidden lines is critical for future safety.
Assalamualaikum. My name is Alia Christina binti Nazri, BS23110318. So today I will briefly explain about the 2015 Ranau earthquake, one of the most important earthquake events that happened in Malaysia. The earthquake occurred on the 5th June of 2015 near the Ranau in northern Sabah. It recorded a moment magnitude of 6.0 and occurred at a shallow depth in the earth crust. Because of its shallow depth, the ground shaking was strong and clearly felt in Ranau and the nearby areas. This earthquake was caused by the movement of local faults in Sabah, meaning it was generated within the region itself. As a result of the strong shaking, buildings and infrastructure were damaged, especially in the areas that close to the epicenter. One of the most serious impacts was the rockfall at the Mount Kinabalu. The earthquake triggered the falling rocks from the mountain, which led to the injuries and loss of life. After the main earthquake, several aftershocks were recorded, showing continued movement along the fault system. Historically, the 2015 Ranau earthquake is recognized as the strongest earthquake ever recorded in Malaysia. This event changed the perception that Malaysia is free from earthquake risk and clearly showed that Sabah is seismically active region.
I'm Vinishri, daughter of Balu, with the matrix number of BS 231101157, and I will be presenting on the review and summary of key findings. The first part in this section is structural damage and building performance. Building vulnerability shows that there were over 500 buildings that were evaluated across 7 districts, revealing that more than 160 buildings in Kota Kinabalu and Kudat are vulnerable to heavy structural damage. Moving on to the regional damage variation. In Ranau, Kota Marudu, Tawau, Semporna, and Lahad Datu, the majority of buildings exhibited potential damage, which is moderate structural damage. Lastly, the material and construction impact. Field observations in Ranau identified that building structures, internal materials, and infrastructural facilities directly influenced the level of physical vulnerability. Secondly, it's the secondary environmental impacts on structure. In this part, we are going to see the triggered hazards. The earthquake was highly efficient at triggering secondary hazards, including 5,198 slope movements. And also, we are going to see the cascading effects. These landslides and rockfalls caused severe physical damage, and it blocked water catchments and resulted in 18 fatalities among hikers. Lastly, we are going to see the engineering and policy implication. Lack of seismic design. This is due to the lack of awareness, the high cost of implementation, and historical rarity of damaging events. Next is the urban planning and mitigation. Using tools such as ArcGIS to identify high-risk areas for future development guidelines help us to reduce risk. And adopting earthquake engineering standards to protect occupants and incorporating natural disaster management into sustainable development planning also reduces the risk.
Assalamualaikum and hi everyone, my name is Siti Naresha, and for my part, I will explain about community impact, risk and preparedness related to the 2015 Mount Kinabalu earthquake. The earthquake caused damage to residential houses, schools, mosques, hostels, and other public facilities. This directly affected daily community activities and safety, especially in Ranau and surrounding areas. Basic services such as water supply and access roads were also disrupted, which increased hardship for local communities. In addition, the earthquake triggered landslide on steep slopes around Mount Kinabalu. This landslide posed further risk to settlements, transportation roads, and tourism areas. In terms of community risk, many buildings in Sabah were not designed with seismic considerations. This made communities highly vulnerable even to moderate earthquakes. Studies show that older reinforced concrete buildings are more likely to experience cracking and structural damage during seismic events. Communities living near fault zone and mountainous terrain also face combined risks from ground shaking and secondary hazards shown as landslide. Therefore, the 2015 earthquake highlighted the importance of improving public awareness and earthquake preparedness. Strengthening and retrofitting existing buildings, especially school and public infrastructure, is crucial. By applying seismic-resistant building guidelines, improving monitoring system, and promoting community-based disaster education, the resilience of community in Sabah can be significantly enhanced. That's all for me. Thank you.